Think your gigabit fiber is fast? For most of us, having a gigabit connection at home feels like the pinnacle of modern technology. We stream movies in 4K, download huge files in seconds, and video call friends across the world with barely a hiccup. But what if I told you that what we consider blazing fast is about to look like dial-up compared to what's coming next? Japan just set a new world record for internet speed, 1.02 petabits per second. That's not a typo. It's a number so big it's hard to even wrap your head around. This achievement didn't just nudge the bar higher, it launched it into a whole new stratosphere. To put it in perspective, that's over 1,000,000 times faster than your home internet. Imagine your slowest download ever, now imagine it finishing before you can even blink. That's the kind of leap we're talking about. Imagine downloading Netflix's entire library in less than a second. Not just a movie or a season, but every single show and film instantly. Or backing up your entire computer, photos and videos in the blink of an eye. The possibilities are mind-boggling. This isn't just a lab stunt, it's a glimpse into the future of connectivity. The kind of speeds that could make science fiction a reality, powering technologies we haven't even dreamed up yet. A petabit is 1,000 terabits, 1,000,000 gigabits, numbers that make our current speeds look ancient. It's like comparing a horse-drawn carriage to a rocket ship. The scale of this breakthrough is almost hard to believe. Japan's National Institute of Information and Communications Technology, or NICT, achieved this with a new kind of optical fiber. Their innovation isn't just about speed, it's about reimagining what's possible for the entire internet infrastructure. The best part? It's compatible with the cables we already have underground. That means this technology could be rolled out much faster and more affordably than starting from scratch. That means we won't need to dig up every street to upgrade. Cities won't have to deal with endless construction, and upgrades could happen with minimal disruption to daily life. This is more than a record. It's a roadmap for the next era of the internet. It's a signpost pointing toward a future where data moves at the speed of thought and where our digital lives are limited only by our imagination. We're talking about the backbone for technologies we can barely imagine. Immersive virtual worlds, citywide AI, real-time language translation, and seamless telepresence. The kind of things that could transform how we work, learn, and connect. It's not about bragging rights, it's about building the superhighways for tomorrow's data. As our world becomes more connected, the demand for speed and reliability will only grow. The new fiber could let us upgrade existing networks without massive infrastructure changes. That means rural areas, small towns, and big cities alike could all benefit from this leap forward. This makes the dream of ultra-fast internet much more realistic. Imagine a world where buffering is a thing of the past and everyone has access to lightning-fast connections, no matter where they live. Japan didn't just break a record, they showed us the next chapter of the internet. They've set the stage for a global race to see who can bring these speeds to the masses first. The future of global communication just got a lot closer. Imagine collaborating with anyone, anywhere in real time, with no lag or delay, no matter how complex the task. Our current devices can't handle these speeds yet, but that's how innovation starts. Today's breakthrough pushes engineers and companies to create the next generation of hardware and software. Today's breakthrough is tomorrow's standard. Just like we once marveled at dial-up, then broadband, and now fiber. Soon, petabit speeds could be the new normal. Get ready, the internet is about to change forever. The next era of digital life is on the horizon, and it's arriving faster than we ever imagined. Let's break down what it really means to move data at the speed of 1.02 petabits per second, a number so huge it's almost hard to imagine. 1 petabit per second is 1,020 terabits, or over 1,000,000 gigabits every single second. That's 1,000,000 billion bits of information racing through fiber optic cables in the blink of an eye. To put it in perspective, that's enough bandwidth to transfer the entire contents of a large data center in just a few seconds. It's a scale of speed that dwarfs anything most of us have ever experienced. The average US broadband connection clocks in at about 250 megabits per second. This petabit connection is over 4 million times faster. So fast it makes today's fastest home internet look like dial-up by comparison. Imagine downloading a massive 200 GB game like Call of Duty. On a typical gigabit internet connection you'd be waiting around half an hour. But with a petabit connection that same download is finished in just 0.0016 seconds, faster than you can blink. In fact, you could download hundreds, even thousands of those huge games in a single second. Your entire digital library refreshed instantly. Streaming high-quality video? A single 4K Netflix stream uses about 25 megabits per second. That's nothing for a petabit connection. At these speeds you could run 40 million 4K streams at once. That's enough for every household in a major city to watch ultra-high-definition content simultaneously, with room to spare. And with this kind of bandwidth, data limits become a thing of the past. The idea of waiting for a download or worrying about overages simply disappears. Downloading files becomes so fast, it feels like everything you want is already on your device. Need a huge video project or a massive data set? It's there, instantly, as soon as you click. For scientific research, the impact is even greater. Facilities like the Large Hadron Collider generate petabytes of data that need to be shared with researchers around the world. With petabit speeds, that data could be transferred globally in real time, accelerating discoveries and collaboration. No more waiting for hard drives to be shipped across continents. Instead, scientists, businesses, and creators can access and share massive files instantly, no matter where they are. This isn't just about faster movies or games, it's about transforming how we move information worldwide, connecting cities, countries, and continents with seamless, real-time data flow. Imagine being able to download every movie ever made in the highest quality in just a few minutes, the entire history of cinema at your fingertips, almost instantly. The implications for science, business, education, and daily life are staggering. From remote surgery to global financial markets, every industry stands to be revolutionized by this leap in speed. With petabit speeds, the world's data flows without friction. Barriers of distance and time start to disappear, making true global collaboration possible. The future of information is instant, always available, and limited only by our imagination. And this future is coming faster than you think. The age of petabit internet is just around the corner, ready to change everything about how we live, work, and connect. How did NICT pull off this speed? By reinventing fiber optics. Traditional fiber is a single glass core, a one-lane road for light. The Japanese team built a 19-core fiber 19 lanes in the same sized cable. Each core carries its own data stream, multiplying capacity by 19. Then they used dense wavelength division multiplexing, DWDM, to send hundreds of different colors of light down each core. Each color is a separate data channel, all traveling together without interference. In total, 19 cores, 739 wavelengths per core, all in a cable thinner than a human hair. This combo of spatial and wavelength multiplexing is the secret sauce. It's a massive leap in data density without changing the size of the cable. That's how you get to 1.02 petabits per second. The 19-core fiber isn't just clever, it's practical. The challenge? Preventing crosstalk or light signals bleeding between cores. Engineers precisely spaced and insulated each core, keeping signals clean over long distances. The new fiber matches the diameter of standard cables, so upgrades don't require new infrastructure. DWDM adds another layer, 739 wavelengths per core across 3 light bands. Special amplifiers boost all these signals for long-distance travel. At the end, prisms and filters separate the colors, reassembling the data. It's a symphony of light, all happening at mind-bending speed. This is the future backbone of the internet. Do we really need this much speed? For checking email or scrolling through social media, probably not. But when we look ahead, the answer changes. The future of connectivity isn't just about streaming movies or binge-watching shows on Netflix. It's about preparing for a world where digital experiences are richer, more interactive, and demand far more from our networks than ever before. Data demand is exploding at an unprecedented rate. Every year, we create more data than in all previous years combined. New technologies, some we can barely imagine today, will require even more bandwidth and speed to function seamlessly. Imagine stepping into a virtual reality world so lifelike, it feels like you're really there. Photorealistic environments, streamed in real time with no lag and no motion sickness. This isn't science fiction, it's the next step in entertainment, education, and even remote work. A petabit backbone could support millions of people sharing these virtual spaces at once, making global collaboration and social interaction more immersive than ever. Artificial intelligence is another massive driver. Training and running advanced AI models requires moving and processing petabytes of data instantly, from anywhere in the world. This kind of power will unlock breakthroughs in science, medicine, and business. Smart cities, autonomous vehicles, and billions of IoT devices will all depend on this level of bandwidth. From traffic lights to home appliances, everything will be connected, sharing data in real time. Consider a single self-driving car. It generates terabytes of data every day, analyzing its surroundings and making split-second decisions. Now imagine millions of these cars on the road, all needing to communicate and process information simultaneously. Only a petabit network can handle this flood of information, delivering ultra-low latency and reliability, so everything works smoothly and safely. It's not just about speed. It's about enabling the next generation of innovation, creativity, and connection. The metaverse, AI-driven cities, and a world where everything is connected all need this kind of foundation to become reality. The future isn't just faster, it's smarter, more immersive, and more connected than anything we've seen before. And it all starts with building networks like this, laying the groundwork for a truly digital future. Zoom out, and the need for petabit speeds is obvious. Scientific projects like the Square Kilometer Array will generate more data daily than the entire internet carries now. Petabit networks make global collaboration and instant data sharing possible. Cloud computing will feel local, no lag, no difference between your device and the cloud. Remote work, design, and even surgery could happen in real time worldwide. This is about future-proofing, building headroom for innovations we can't yet imagine. Just as broadband enabled streaming and social media, petabit speeds will unlock the next wave. We're laying the groundwork for a digital revolution. It's not just an upgrade, it's the foundation for what's next. When can you get petabit internet at home? Not soon. This is Backbone Tech, the superhighways connecting continents, not your driveway. The last mile to your house is the bottleneck, still using old cables. Even if you had a petabit line, your devices couldn't handle it. Your SSD would choke on the speed. For now, this tech lives in data centers and undersea cables. But as the core gets faster, everyone benefits: better streaming, lower latency, more reliable connections. You won't see petabit on your bill, but you'll feel the difference. The internet's about to get a massive upgrade. Japan's record is part of a global race for internet supremacy. Countries like the US, China, and those in Europe are all pushing for faster, more reliable networks. It's not just about pride, it's about economic and strategic power. The leader in communication tech leads in AI, finance, manufacturing, and more. China's building massive fiber networks. US tech giants are laying private subsea cables. This competition drives innovation and sets new benchmarks. The tech behind this record, multi-core fiber advanced DWDM, will soon go global. The race is on, and the finish line keeps moving. What does this mean for the future? The digital world is about to get much bigger and faster. 1.02 petabits per second is just the start. 10, even 100 petabits are next. The new fiber works with existing infrastructure, so upgrades can happen step by step. As the internet's core gets faster, everything else will follow: processors, routers, and new apps. It's a cycle of innovation driving new possibilities. This isn't just a speed record, it's a leap for human connection. From telegraphs to gigabit, we've always pushed the limits. This is the next chapter, a world where distance disappears and information is instant. The future is coming fast, thanks to breakthroughs like this. Get ready for a world where speed is never the limit.